With no experience, can you just grab a stick welder and teach yourself to weld? And can you make something useful while you're learning?
Oh no! That didn't work so well.
We're on fire, no problem. That was a weld! That was a weld! We're converting this outbuilding into a workshop. That means we need to put some security in place to keep the valuable kit inside and not on somebody's market. So the challenge for this video is, can we make some window bars to fit these windows? And along the way, I'm going to attempt to teach myself to weld. Now, I had a price for window bars for this place, $1,500 for 7 windows, and that just seems too much to me. So the final question we have is, can you save money by welding up your own window bars? Spoiler alert, yes, you can teach yourself to weld, yes, you can make something useful, and yes, you can save money by welding your own window bars. And if I learned anything here, is that I should have learned welding years ago, because it's much easier and cheaper than I thought. I thought it was one of these skills where you need someone to show you how to do it, or you need to go to a course. Nonsense. Get a stick welder and just get stuck into some welding. It's amazing to me. I spent thousands and thousands and thousands of dollars on equipment for woodworking. I know how to plaster, I can pour concrete and things like that. But welding is actually fairly simple, or certainly, you know, something that isn't going to be some beautiful piece of panel beating welded together. Something like this, very, very easy to weld. And it feels great to take pieces of metal, things which are very, very solid, and just melt them together and make something seriously strong. So my plan for this window is that we will make a frame from flat stock. We'll then create the bars running down, and between those bars we'll have small pieces in a kind of staggered, almost vertical brickwork pattern. And the purpose of those is to stop somebody from popping a jack in between 2 bars and jacking to force the bars open. Then we will fix the entire frame of bars into the window using a round rod drilled into the brickwork and then welded up, and that should be super strong. First thing, let's measure up, see what size we need. I'll take measurements at 3 different levels here, so that's 94 centimeters, or Y inches for our American friends, 95 centimeters, 93. So I'll work on the smallest measurement there because I want to build a rectangular unit, so we'll work at 93 centimeters. In height we are 126, on this side 127, and the center will be huge, so 1285. So we'll work at 126 high, so we're looking at 93 by 126. So now we've got our measurements, we can set off by a cheap, very basic arc welding stick welder machine, the steel stock that we'll need, a couple of grinding discs, and that should be everything that we need. Off to the shops. We'll go up to Tesco and buy a welding machine. Now I'm sure we could get a fancy professional welding machine, no problems, but I figure if we can do this with the cheapest machine, universally available, you know, I'm sure these things are exactly the same around the world. If we can make that work, then hopefully there's something for everybody to learn from this video. Well, unless you're actually a welder, in which case you'll learn absolutely nothing from me. So the woman says they don't sell welding machines, it's a supermarket. Well, here's a welding machine. One arc welder. It's not super cheap. It's just over 100 euros, so about $120. Well, it's cheap enough, so we'll take this. I'm sure it's the most basic inverter welder going, and they sell welding rods as well. 2 types. We'll take both because I have no idea what the difference is. And these are European standards, or European numbers on these. So we've got an R143 and an R144. I don't know what the difference is, but we'll find out. The Google will help us out. We're going to the metal merchants now. Simple name, pipes and metal. Nice and easy. We'll go there, grab some stock, head back, see if we can join it together in some sort of strong way. Aha! I see it, it's huge. So I've just finished in the Steel Merchants. These guys are really nice. They're going to cut the lengths for us, or to the nearest millimetre or so, which is perfect. That's going to save us a load of work with the angle grinder, and the total cost for everything we need for 2 windows is around $30. So that's way less than half what we would have paid for those windows. So I'm pretty happy with this place. We'll be back in an hour to collect the cuttings. One of the things with a project like this, where you're stepping into the unknown, is finding suppliers, because it can be very hard to find someone who's friendly, decent, good prices, good service. We hit the jackpot with a steel stockist here. Not only did they have good prices, good quality stuff, massive range, but they also cut everything to length for us, which saves an enormous amount of time, because I thought we would be using the angle grinder and cutting all this to length ourselves. So what we've got is some flat bar for the frames. We've got some 14mm kind of 5/8 inch square rod for the actual bars themselves, and the guys that gave me prices for these were quoting for 12mm bar. This is 14, which is actually quite a bit more heavy duty, so that should be good and strong. And then the real time saver for us is we've got these little pieces all cut to length, 100mm long, to make nice crossbars across the windows. So we'll take this into the workshop, but then the number one challenge that we've got here is, can I actually weld any of this together? I can't help myself. Everywhere I go it ends up looking like a scrapyard. Look at the state of this place. It's a work in progress, okay? We don't need a fancy welding table for this, just a couple of sheets of flat board. In our case we're using OSB. And what is important is that this is a flat table to work on. So take a straight edge and just lay that across the table and check that there's no gaps visible underneath, and check that at various angles and points across the table. That's all good. Welding onto this wood is going to cause it to be scorched, so this will be covered in burn marks. So make sure you use something that you're not hoping to use as decorative material somewhere else. Okay, here is our welding machine. This is the cheapest, I'm sure, bottom of the range stick welding machine that you can get your hands on. Pick this up at a supermarket. It's available anywhere in the world. This is the first time I've ever touched a stick welder, but I spent some time reading about it. So let's see what we've got in the box. Instructions, I don't think so. Some plastic, some cables, a chipping hammer, and wow, this is a welding mask, but I actually have an auto darkening welding mask, so this won't be needed. Stick holder, which is where we stick our welding rod, and the machine itself. It's so light. This is an inverter welder, which is a more modern equivalent of the heavier transformer based welding machine. So basically what we have here is this machine generates a voltage and a current, and to generate that, traditionally you would have had a big copper box wrapped in wires that's essentially a transformer that generates voltage. And these inverter welders use semiconductors, electronics, to do the same task. And that means that they weigh a lot less, because you haven't got a huge chunk of copper inside the machine. This thing weighs nothing, I would say 5 pounds maximum. So with arc welding or stick welding, there's 2 different types of current. Basically, we've got alternating current welding, which is a little bit more tricky, I'm told, than DC welding, and DC welding, direct current welding, which is what we've got here. Now, all of those machines take AC, alternating current, as their input, but a machine like this converts that AC into DC, and we use that DC to weld. Now with DC, there's 2 different types of DC welding. There's DC electrode positive and DC electrode negative, and this machine, you can choose which you use by plugging the cables into there. So what we have, we should go back a little bit here, let's rewind. We have our machine and we have 2 cables. One is the earth cable, which we would connect to our metal that we're about to weld, or if you had a metal welding table, then they connect this to the metal table, leave it connected, and the metal table and the pieces that you're welding are all connected together basically by resting on each other. We have a wooden table, so we'll need to clamp directly to the pieces. Then we have our electrode holder, and this is just a basically it looks like a, I'm not even sure, okay, this is a clamp. We insert a welding rod into here and then connect this to, in our case we want to be DC positive, so we'll connect the electrode to the positive output of the machine, and those two cables form a circuit that goes through the workpiece, generate that voltage, and we're going to create a small spark, a little lightning bolt between the end of the electrode. Hold on, let me get an electrode. I've no idea how long one of these electrodes lasts, how much weld you get out of one, but we'll find out. Here is an electrode. We'll pop that in the holder. Let's have a look at how this would actually work. So we would connect our earth to the negative, which is here. How does that fit? You twist it and it locks. Interesting. And our positive would plug in here. So now if we were to weld these two pieces together, we'd pop those on the table, we would connect our earth to one of those pieces, and there we go. And now if we were to weld there, I mean, I'm hopeful, I never actually did any welding, so I'm freestyling here. We would use this electrode here to touch close to the workpiece, and there would form a little, basically a lightning bolt, or an arc as it's called, between the two. And you know, lightning's hot, I'm sure everybody knows that. That creates an enormous temperature, melts this rod, which forms the filler metal to fill this gap up. And also around the edge of this rod is a powder, which is called the flux. And that flux melts, releases carbon dioxide gas, which shields this weld from the air. Basically, the carbon dioxide is emitted and takes up the space where air would be, so air can't come into contact with our weld. It also has chemicals in the flux which form a slag, so they suck all the impurities from the metal that we melt up towards the surface, and when this weld cools, there'll be a coating on the top, which we call a slag, which basically has all the nastiness from the metal in one place. And once the weld's cooled, we can knock off the slag, and that leaves us with a nice, good quality weld. I mean, hopefully, I should think that my welds are not going to be good quality, but at least the metal in there will be good quality. Let's talk a little more about the welding rod itself. There's different types of welding rod. This one is an E6013, which seems to be a very general purpose welding rod. And we have two different sizes of rod here. I have no idea which is best for this sort of task, so I got both. This is a 2mm diameter rod, and we also have a 2.5mm diameter. I'll try both of those and see what happens. The thing is, this looks so simple. It looks, you know, really, really straightforward. The reality, I think, is going to be that it comes down to technique. But anyway, into the deep end. Let's hook this all up, get the safety gear on, and try a few welds. I am dying to get stuck in here, but first, just let me remind you, I'm not trying to teach you how to weld here. I don't know how to weld. I'm about to make my first weld, strike my first arc. What I thought this video was good for is to share completely honestly my first experience of welding, and with no instruction behind it, just watching YouTube and trying to teach myself from there. I don't know how this is going to go. Maybe this first weld is going to be an absolute beauty. Maybe I'm going to set fire to the table. I have no idea. We'll find out. What you need for welding, you need a pair of welding gloves, a welding helmet. We'll talk a little bit more about that in a second. You obviously need a welder. I've cut some scrap stock here, just some flat bar, which I'm going to practice running beads on, try and get some arcs started, just basically see what happens. We need a welding rod, obviously, for the holder, and then for extra safety, in a mild emergency, I have a bucket of water. We'd want to get this out of the way first if it's turned on, plugged in. And for a serious emergency, on my right side, I have a powder fire extinguisher. And I really don't want to set off a powder fire extinguisher because they make a massive mess. But if it's that or the workshop burning down, I'll take the powder. Let's talk about this welding helmet. This is a auto darkening solar powered welding helmet. There's no battery in here, and it's powered by this little solar panel up here, it seems. On the left side, we've got a dial which runs from 9 to 13. I have no idea what those numbers mean, but 13 makes it the darkest. So I'm going to start with it at 13, and then if I can't see what I'm doing, I'm going to work my way down until I can actually see what's happening. On the inside here, I'm not sure if you'll be able to see, we have some various toggle switches. And the important one you want to be aware of is one that switches between grinding and welding. I think if you've got this set to grinding, it's triggered maybe a lot more easily or something along those lines, and maybe that's going to be bad for your eyes. So I think I've got this set to welding, which seems to be the sensible thing. Delay time I've put as fast. Sensitivity I've put as high. So I've basically gone with what I think are the most cautious options for this helmet, and then I'm going to slowly kind of work my way down. I think that's a better option than to start with the more loose parameters and kind of blind myself and then work my way back from blindness. I'm going to pop this longer lengths of flat stock on the table here, because I think welding these small pieces, they're going to get extremely hot. I don't know how much heat this table can take. I don't know how much heat is generated. So it seems sensible to make a sort of poor man's welding table here, laying a couple of pieces of flat stock there, and then using them as a kind of heat sink, and then placing the piece that I'm going to weld on top of them, and just playing around with some welds and arcs on there. And this way I think I can ground one of these pieces of flat stock, and that way it will pass all the way through to the piece. On the other hand, I think actually I will clamp the piece directly, because that holds it and stops it from moving around too much. We need to set the ampage on the machine here. Now, if I remember right, hold on, let me find the welding rod box. So on the rod box, it says amperage 50 to 70. So I'll set this right in the middle at 60, and that gives us some wiggle room. So we'll pop a welding rod in there, the correct way around. I have no idea what I'm doing, as you can tell. There we go. So the one thing that I do know is that as you weld, you want to keep the cable behind you and steady your arm. So maybe I'm going to weld like this. No, maybe I'm going to weld. Yes, this feels good. To hold the rod at a decent distance there. Right, we're going to go for it. Now, I don't know how to weld, and my camera guy doesn't know how to film welding, so really we're all flying by the seat of our pants here. But anyway, I'm going to put on my welding helmet, put on my gloves, turn on the welder, which is on. Nice whirring noise from that. With striking an arc, what I've read and what I've seen is that it should be like striking a match, and I think we should be working the weld towards the camera, so I'm not even going to really attempt to steady my hand for this first one. All I'm aiming for is to strike an arc and hopefully see some welding anyway. Right, here we go. Ready? Okay. It's kind of sucked the stick and wanted to stick there. I didn't want that to happen. Oh, sparks. Damn, it sticks unless you keep it moving, it seems. Okay, we're getting better. Let's try going this way again. Aha, I can see, so not quite a puddle. Ah. Jesus, I've started welding the clamp there. All right, let's turn this off and examine my handiwork. I just remembered I had a few welding clamps in the garage that someone gave me a while ago, so I'm sure they'll be useful. I've got two of these hammers, which I think are for taking slag off. But let's see what we've got. I got quite carried away there. I ended up welding the earth clamp here, but never mind. I don't really know what I'm looking at, but it seems that some metal has been deposited on the surface, some sparks were made, heat was generated, so I'm going to consider that a reasonable success. We certainly struck an arc because there was welds going on. It's still kind of pretty hot, but there's definitely some welding gone on here. Aha! So this black shiny stuff is the slag, and this is a pretty nice looking metal. I mean, it's a complete mess, obviously, but a weld has been made. I'm pretty happy with that. Lots of slag. I'll brush that off. Okay. I'm going to turn this over and try and make a straight line, or attempt to make a straight line. I have a feeling from the videos that I've seen that I'm moving maybe too quickly here, or maybe we don't have enough amps. So I'm going to go in for a second attempt at this. I'm going to use this welding clamp. They seem to be all different funky styles. This would seem to me the most sensible, so it's kind of like vice grips, I think. We just clamp that down. In fact, let's do it that way for some space. And I've earthed this metal here, so we should be good. So helmet on, gloves on, and we'll go for it again, and hopefully this time make some form of straight line. The helmet seems to be working fine. I can see what's going on. Welding round 2.
Okay, I got too far away there. I'm going to go again.
Damn, that got completely stuck there.
So you can't just stab it, you have to brush it. Oh no, it was...
Maybe we're too high on the amps because it's getting stuck. Take it down to 60 and we'll try again.
Oh no!
The rod seemed to get stuck to the piece a lot more. This time it got so stuck that it actually came out of the holder and stuck to the piece, but it just broke off easily enough there, so we'll pop this back in and try again. I'm not sure why this has become much harder now. I'm maybe thinking it's to do with this clamping that I've got, because it just seems to stick to the workpiece every time I try. Let's try a different clamp. Let's try this one. Well, that seems happier.
Now there's some magic distance. If you're too close, it doesn't seem to work, and if you're too far, it goes out. So there we have, okay. That looked like it was working for a moment there. Let's try again. Now this is a weld. I can see a weld. Ah, it's gone out.
But that was starting to work.
I think you have to be moving as you touch the piece. Yeah. Oh.
I've got carried away welding into the clamp. We're starting to get some things that look a bit like welds, although I keep hitting the clamp. I'm going to swap this piece now for a fresh piece and see if we can get one straight line all the way down. The problem that I'm finding is when I'm starting, it's kind of random where the weld starts, because half the time the rod sticks to the piece. I'm on the right track though. That was a weld! That was a weld! Look how straight that is. I found the distance, and to maintain the distance you have to feed the rod in at a certain rate, and somehow by magic there I hit the right rate. I had a cup of tea, my piggy cup. Let this stuff cool down. Oof, that's still pretty hot. What I think might be easier is welding left to right rather than backwards to forwards or forwards to backwards, whichever way I'm going anyway. I've exhausted the scrap stock that I've got. So now I'm going to try joining some of this stuff together and see if we can make two pieces into one. The magic of welding. I'm going to lose these welding supports that I was using because I think we won't get a flush join otherwise. All I'm going to do is just butt these up against each other, clamp one of them and weld straight in there. So what I'm going to try to do here is I'm going to try to make a tack weld. It's just a little dot of weld basically that holds something together.
And I think it's okay to touch it while I weld it.
I can hear that rubbing together. And is it joined? No. That's a tack weld. That is tacked. If we move that, that is one piece. It's one piece! So we've made a little tack weld here. It's actually pretty nice. I'm not sure if that's how they're supposed to look, but that's how I imagine them. So I'm going to run the rest of that weld now. Woo! Let's dip this in some water, which is bad for real welds. Whoa! Now that was hot. You can see it's still hot. You can see the water all evaporating. Let's use the last of this rod
and make a perfect weld. Aha!
That wasn't successful. Weld fever is in full force down here. I'm going to attempt to join these two pieces of steel on their ends. Let's see how this goes. Let's leave a little gap. I'm curious what happens if we leave a gap.
Jesus.
Jesus. It firmly stuck to the metal and just would not come away. Maybe the current's too high. Let's turn that down. We've got a reasonable weld. Well, it's not great. Let's turn it over, try again. That's a real looking weld. That is pretty nice. That's enough practice for me. I think we'll learn on the job. So we'll set up for these window bars. We learned a lot here. It's okay to weld on this OSB. It's kind of scorched, but it's certainly not a risk of catching fire. The machine works, the welding mask works. I don't feel in any way like I'm risking my health or doing anything dangerous. It feels quite safe. Let's pull some of this metal up, set up for these window bars, and attempt to actually produce some product. We're laying out these window bars now, and it's vital that they go down square, parallel, and in right angles to each other. So what I'm going to do is just mark 5 centimeters from an edge which I know to be straight. So on here, this is the machined edge out of the factory. So if I just bring in 5 centimeters from there, various points along here, then we should be able to hammer in some nails along that line, and that will hold our piece exactly the right spacing. There we go. So we've got our long side piece in. Now I want to put my bottom, so again I'm going to run in 5 centimeters from this left edge, which is definitely straight. We'll double check this once we've laid out our frame, and I'm not sure if I'm right to start with the frame, but I'll try it with this one and we'll see how we go. So we'll drive a few more screws in. I'm sure that there's more efficient ways of doing this, but we don't have any fancy equipment here, so this is the way we'll do it. That's about right. That seems happy with 2. We'll put a third one in here just to hold that vertical. So if we drop the bottom in here and we take a measure of the bottom, that's 126, exactly what we want. That's the height of the window. And over here we bring in to 126, that's good. And now if we insert this piece in between these, now we want to square this up. And the way to square up a rectangle is we want the diagonal measurements to be exactly the same. So in that diagonal we're 1565. The opposite diagonal 157. That just needs to be pushed slightly in this direction. Double check that we've got a perfect rectangle. Just a quick sanity check in the opposite diagonals. That's 1562, 1561. Thank you, Pythagoras. So I'm going to use these newfound welding skills, which seem to kind of work, to weld up this frame. I'm going to start by tacking all 4 corners, and then I will try to run weld uphill in the corners. I'm not sure how that's going to go, but fire in the hole, welder on, clamped up. I'll start in this corner here. That didn't work so well. Let's try another corner.
And never mind tack welding, let's just get right in there.
That is welded. That is welded.
Here we go for another corner. Oh.
We're on fire. No problem. I'm learning quite a bit here. I mean, welds are going down. It seems to be working. Stuff's stuck together. This weld looks like it's more on this piece of material than this one. I'm not sure why that is. I wonder if it's because the earth clamp is on this and therefore it's kind of drawn more towards this one. I'm not too sure. What I'm going to do is I'm going to go around the outside and weld up the outside of these joins and see how that goes. We've got a big blob of weld, and hopefully I've managed not to weld this yet. I've not welded the screw to the frame there, but there's a big blob of weld hanging down. That's probably not good. We'll take the grinder to that. Maybe, I think it's possible that these welding rods are too thick now for this job. I'm going to try the smaller rods. Now that seems better. That's much better. We've got one more outside corner to do, and it definitely seems the smaller rods are the way to go here. Although, in this case, it looks like a drunk has welded this. We have a frame welded up. I'm incredibly pleased with how this has come out. Is it going to win any prizes? No. Is it ugly? Very. Is it kind of stuck together? Definitely. It's pretty strong. And it's square, which is the more important thing. I'm going to drop these 2 pieces of flat bar in there just as spacers, because when I lay these bars, I want them centered on this flat bar. I don't want them resting on the bottom. We'll put those in there like that. Bring in some bars. Hope that I measured everything correctly. We'll start in the middle and work our way out. So I'm going to space these bars using these 100mm cross pieces. I'll just drop 2 in. I'm not going to weld these. All I'm going to do is weld these bars top and bottom for now, and then I'll come along later and insert all these cross pieces. Just space these bars all the way along here using these. This is coming together quite nicely. I know that we'll end up with an irregular gap at the other end here, and that's okay. I'd prefer that we have slightly asymmetrical bars here, and I only had to cut 2 or 3 of these by hand with a grinder, rather than center it here and have to cut both sides to the exact dimensions. So we can live with that. I'm actually surprised how easy this is so far. We've got all our bars in place. This last gap here is slightly smaller, but no problem. We'll cut some custom cross pieces for that. Now I'm going to weld these bars in top and bottom. Before I do that, I'm going to just quickly check that we're still square. 156, 156. So I'm going to try the thin rod, which seems to be working well on these small gaps, to weld these bars all the way along at the top, and then I'll work the other side, and there's a slight bow there, so I'll push the bottom edge of the frame in to catch and get in nice and tight. That should keep everything together. So here we go. So it's not worked out quite as perfectly as I was hoping. Some of these look good, but when it comes down to it, when I actually wiggled these bars around, they just broke. You know, they look like they're welded, but really they're incredibly weak. So, in fact, if I take out these, look at that. It's just cracked right in the middle of the weld. So, I don't know what to do there. I think I'm going to experiment with thicker welding rods. There's more lessons to be learned here. Definitely something that comes down to practice and experience, neither of which I have. Success! We've welded up these window bars. I spent hours practicing these welds. The first few welds that I made just did not go that well. Things would just fall to pieces when I hit them with a hammer, but I stuck at it, I persevered, and I think maybe 2 hours or so I had this finished. And then what I've done is I took a grinder and ground these welds down to make this look reasonably good. The saying, grinder and paint makes me the welder I ain't, definitely applies to me, although there's no paint. Window bars actually are a great project to learn to weld because they don't need to be beautiful, they're functional in nature, which is lucky because my welds are all fairly ugly. They are not safety critical. I mean, they are in the sense that we don't want somebody just tickling these and they fall to pieces. But window bars are psychological in nature, particularly those on the inside of the window. So if somebody's already smashed their way through the window and these welds turn out to not be incredibly super structurally strong, then, you know, unfortunately, that's just what's happened. But they are strong, and this has actually worked out great. So what I'm going to do is share a few tips that I've realized, well, not even tips, basic things that I learned along the way of making this first set. So I'll share those things with you, and then I'll go back and make another set of bars, and then we'll fit them to the window. So hopefully you can learn from my mistakes and the things that I had to learn the hard way, some things that weren't really made clear when I did my research on this. Hopefully this sends you the right way. Number 1, long sleeves. If my arm looks sunburnt, that's because it is. If you're doing a lot of welding, if you're just doing a couple of welds, it doesn't matter. But if you're doing a lot of welding, which I was, slowly, painfully, you need to wear long sleeves because otherwise you're going to get suntan or sunburn, too much exposure to the UV light in the welds. So I'll wear a hoodie, even though it's 30 degrees outside, but we'll suffer it out. Second, this rod holder, the electrode holder here. Now when I was doing the welds, I just assumed that this is how you put rods in there, you know, like a magic wand. Actually, you can put the rods in at all different angles, and it's much easier at 90 degrees. It was easier to hold 2 hands on here rather than try and sword fight my way across the welds here. It was much better at 90 degrees. Felt I got much more accuracy there. It took me, I would say, at least an hour to realize that you can put a rod at different angles in the holder, so that definitely helped me. And while we're on the topic of rods, these are 60-13 rods. Now, I don't know the difference between these rods, but there's different standards of rod, different types of rod. This is what's called a 60-13, I didn't really like making welds with this. It didn't seem to be working. I tried a few different currents, and to be honest, it just was not that successful. So I tried different thicknesses, and I ended up with using what's called a 70-14 rod, which seemed to make much stronger welds. But then when I went back to these 60-13s later, having kind of learned to get a feel for what was needed, these were working well. So I guess what I'm saying here is try a few different rods, try a few different sizes, experiment with the ampage of the welder. Eventually, you will find one that seems to work for you, that seems to come together. And then if you go back to the other ones later with some experience, you might find that they work great for you. On the rods themselves, it's printed what this rod is. So it's printed here, E6013. So you can tell what a rod is. It doesn't seem to tell you the diameter, but you can eyeball them, and that's a 2mm rod. The other thing with rods, which I had no idea of, is how many welds you get out of a rod, or how long a rod lasts. One rod probably was enough to do maybe 5 or 6, maybe 8 maximum of these little welds here. So you really don't get much mileage out of a rod. In fact, to do this whole grid, I would say probably took maybe 25 rods, something like that. It took roughly this amount of rods, a bundle this size. Seems a lot. The other thing that I found was that the ground connection's very, very easy. You just clip this onto basically any piece of metal that's joined to what you're going to weld. The pieces that you're joining don't need to be touching each other. Only one of them really needs to be grounded, and the rod will then fill that gap up. So as long as you have some earth connection to the point next to where your rod is touching, you're going to be fine. But the biggest thing I learned is that welding is really, really good fun and also massively productive. So already I fixed my wheelbarrow that had a small hole in it. I welded some piece of steel onto a door. It's actually really quite straightforward to get going. You know, honestly, I was a little scared when I started using this. I'm not scared, but you know, you don't know what the risks are. Am I going to get burned? Am I going to get an electric shock from touching things? Is the whole place going to burn to the ground? And the reality is it's actually quite safe using this thing. I got a couple of burns where I touched things that were red hot. The stuff stays hot for a lot longer than you think. I also got so excited that I would put the welding mask up to have a look and see how I was getting on, and just got so excited that I would just continue welding and forgot to put the mask back down. And this thing is bright, so you only make that mistake once. What else did I learn? I don't know. Get stuck in. This is the way to learn. Grab some project that you're going to have fun making, get welding, you'll learn along the way. It's really not that hard. Having made one set of window bars, I'm now going to make the second set. Hopefully you can kind of follow along as I go. Maybe I'll remember some stuff that I learned, but in any event, I'll actually do this properly now, hopefully. fact, I enjoyed this so much, I'm gonna sit here and philosophize for a second. This has been one of the most satisfying projects I've done, I think. I saved money, which is the #1 brilliant thing. I had fun. Also great fun. We made a load of sparks and I learned something new. It's just blown my mind how accessible metalworking and welding really are. If you have a good steel merchants that will cut your stock to length, then you give them a list of measurements, they cut everything, you bring it back and you weld it together like a piece of IKEA flat pack furniture. It's not rocket science, it's not difficult, really a lot of fun to do, and you can get some great results. To get something useful using woodworking, for example, if you're going to make a dining table, for example, you need expensive tools, you need a fair range of different stuff, and the wood itself is often quite expensive. It's expensive to make things from wood versus their price from big box furniture stores, flat pack furniture. It's much cheaper to buy it ready-made. For welding and creating things from metal, the metal is surprisingly cheap. I mean, for its strength and its volume and the amount of use that you can get out of it, metal is actually cheaper than wood. All you need to do this is an angle grinder, a couple of different discs, a welding machine, and that's basically it. Go for it.